Hello, I'm David Mason. I'm one of the senior markers from the standard courses. Today I'm going to go through some questions from Standard 1 first and then into Standard 2. Standard 1, first of all, question 19. This question required students to read off a straight line depreciation graph, and there are a couple of other things that they needed to do as well. Converting years into months was one of the things that some students were having some trouble with, and then also interpreting the graph in terms of the limitations that we can obtain from that. So question is there and some sample answers. Some of the positives from this were that the majority of the students did actually attempt the question and had some success somewhere in the three parts there. The better responses, the students were able to first of all show the conversion correctly from years to months, and then they went into the graph to get the correct response from the graph. Some students were able to identify that the graph would give a negative value for the car at some point in time, and that this was unreasonable. Having said that, a lot of students didn't see that connection. Some of the errors that were in this were that many of the students struggled to determine the missing values on the axes. So not so much across the horizontal axis, they were able to get that the missing numbers went up by 10, or the numbers went up by 10, but they did struggle with going between 4,000 and 8,000, 8,000 and 12,000, etc. So that made some issues with them in getting some of the answers. If you look at the graph, the line stops at about 82 months, and many of the students thought that this is the current time and didn't know how to answer the last part of the question in the way it was intended, which was that eventually this graph would show that there was a negative value for the car. So there were some issues around students interpreting what was being asked in the question and what the graph was actually saying. Some of the learning outcomes I think that we as teachers need to look at here is that students need more practice in determining and applying the scales used on graphs. So in this case, we might think that this is fairly straightforward, but a lot of the students did actually have some issues with that. Students need to have more exposure to mathematical models in a real life situation. We teach a lot about showing graphs, linear and non-linear graphs, but when we start to put conditions on it, the students are not getting, obviously not getting enough exposure or enough understanding to be able to apply those in the real life situation. They also need to develop their skills in identifying the limitations. So that goes hand in hand with the previous part. They need to be able to identify that there are limitations in the models, and that we can't just take the graph entirely as it's shown. The next question we're going to look at is question 23. It was a travel graph, and students had to recognise a few things in this. Rest periods, the fastest travelling section of the graph. They needed to be able to draw a constant speed graph, and they needed to make some interpretations between what was being shown from the graph they had to draw and the given graph. The left-hand side there is the question, the right hand with some solutions. Pretty basic, we would probably think. However, some students did struggle. Positive, most students attempted the question and had some success again. Most students were able to get a mark in either part A or B in this particular one. Many of the students actually created problems for themselves because if I go back, as you can see on the graph here, they have letters in a straight line section. The students actually took that as being the endpoints of a section, and even though they should have had an extra one, they were giving answers such as CD, section CD, meaning the line that was a straight line, not the two sections. So there was an issue there. Many of the students interpreted the longest section, which happened to be section D, as the fastest travelling because it was the longest section, or that they had some reasoning behind it of that sort of nature that showed that they didn't realise that they were looking for the steepest section, and that could have been the shortest section of the graph, but it was the steepest, not the longest section. This is another question that the students didn't really interpret the axes properly. Some of them took that the end point of a section was how far they travelled in that section. So if you were to look at section D finishes 6 kilometres from the start, but they were saying that it was 6 kilometres that they travelled in section D. A large number of the students had some difficulty in determining the horizontal scale here. Because it was broken up into 8 sections between each hour, they really did struggle with this. In some cases, as I've shown here, they would be looking at it as 8:25 a.m. They'd be writing, meaning 8:15, because it was a quarter of the way across. And even a simple one that we would think 8:30 should be written, they'd put 8:50. So they were looking at it as a decimal of hours as opposed to the actual time. So to me, that shows that there are quite a few issues that students have in using scales for time and how that was broken up. Most students attempting part C struggle to get the correct straight line. Many of them obviously didn't have rulers and were using pencils or pens as a guide, because you could see where they tried to join it back up. Some of them drew freehand graphs, and obviously they became curves to some extent. But the most common error was that they would start at the end of A, so at 7:30, and join up at the beginning of F, which is at 9:30. So you had a straight section, another one straight section, and another straight section at the end. But it didn't form one straight line. And that again comes back to some of the way they interpreted the labeling of the graph, and probably not really reading the question as it was meant to be read. So some learning outcomes. Students need to understand that a travel graph, the horizontal line or horizontal section of the travel graph is at rest, because that was not very well done. And the steepest section will give the greatest speed. Simple things to pick up, because they're common sorts of things that we're going to be talking about when we ask questions on travel graphs. They also need to understand that if you're asked to draw a straight line that represents something, that's a constant speed. Or if you're told that you'll travel at a constant speed, then that means it's going to be a straight line that you're going to draw. And the last question we're going to talk about from this Standard 1 paper is question 26. It involved scale factors, where they had to convert the lengths of one diagram into the appropriate lengths in the second diagram, and they needed to calculate the area of the larger shape. So there was two shapes: a smaller shape made of a rectangle and a triangle converted to a larger one. There are a couple of issues with this. Students didn't look at this very well, and they looked at the 9 centimetres in the first diagram as being the height of the rectangle, not being the height overall. And that was one of the first issues. And the other one was how they calculated or how they determined the area of the length of the base of the triangle. But we'll get to that in a minute. So positives: many of the students made an attempt to calculate the area of the large shape. This was despite whether or not they could actually do the conversions of the lengths properly. At least they made an attempt to calculate the area of the large shape, which was what the question was after. The better responses showed some structure working out. Not necessarily for the conversion of the lengths, because they were often just written on the diagram. However, using those to calculate the area was important. The most common errors that we saw were people were adding 1.5, not multiplying by 1.5 to get the new dimensions. And as I said, many of the students struggled to calculate the area of the triangle. In this, what they were tending to do was say, well, if the length of the base is say 20, well, half the base is 10, and that would be the base length of the triangle that they would put into the half base times height formula. So it was like they were finding half of the triangle, but they then didn't double that to get the whole triangle. That was one of the big errors. Another one that came from that was also finding the area of the rectangle being the whole height times the base length, as opposed to just the height of the rectangle. So from this, students need a bit more practice in using scale factors to find unknown lengths. Either scaling up or scaling backwards doesn't matter. They need to be given a little bit more practice in that, so that they can make those the understanding that they have to multiply, not add. They also need some more practice in deconstructing composite shapes, because that was part of the issue that they had in calculating the area. And students also need to know how to calculate the area of a triangle, especially when in this case, it had a line to show the dimension inside the triangle, and it makes it look like it's two triangles. They need to be able to deal with that situation. And that's the end of Standard 1. The Standard 2, we'll go through 4 questions. Firstly, question 22. It was an income tax question. So the things involved in this question were to calculate the taxable income, from that calculate the tax payable, and also calculate a Medicare levy. And hopefully they would add all that together to get the total tax payable. The question gave the tax table, it gave some allowable deductions, and even told you what the Medicare levy amount was, 2%. Most students were able to identify the correct tax bracket, whether that was writing it down. More commonly, it was putting a mark or highlighting the appropriate line in the tax table. And that was good for them because it actually helped them to gain marks in that at least they knew where they were working from. Many students attempted to calculate the income tax or the Medicare levy. That doesn't mean that they always got it right, but they at least attempted to do that. And again, by showing their working, it meant that they were able to get some marks. The better responses obviously showed structured working out. They showed things in a logical order, and they didn't just write answers down, which gives the opportunity to get some marks for working. Some common errors. They added, not subtracted, the allowable deduction. So we ended up with more that we had to pay tax on. Some of them were leaving the allowable deductions to be subtracted from the income tax that they would pay on the $84,000. So they worked out what the $84,000 was, then took that off the tax that was payable there. That was also linked with, we calculate the income tax, then we'll add in the Medicare levy, both calculated on $84,000, and then let's take away the allowable deductions. Another thing that was common was they'd work out the income tax either correctly or incorrectly using the taxable income, and then they would work out the Medicare levy based on what was the income tax they had to pay, not the taxable income. Nothing surprising in the next point, I'm sure. Students need to convert the 32.5 cents into $0.325. They don't do that. Even if they write 32.5 cents times a number, they don't then still treat the answer as a dollar amount instead of a cents amount. So to me, the easiest thing is to get students to start with, make that conversion before they do the multiplication. So students need to check the reasonableness of their answer. I've said this before to people that have been and seen presentations with Manswa. The amount of times that students don't see that they're paying more tax than the income that they actually earned and don't realise that there's an issue, that needs to be fixed by us. We need to encourage them to look at their answers for reasonableness. The next question is question 27. This question gave some two TVs, a price and some power consumption, and then students had to do some working out from there. Some of the things they needed to do, they needed to be able to convert from watts to kilowatts. They needed to calculate annual consumption for a TV and then also work out what is the cost of that, of using the TV for that time, and then calculate some differences between two items. So the question gave a table with television A and television B, gave the price and different power usage for those TVs. The cost was given in cents per kilowatt hour, and it gave how many hours a day on average the TVs were used. While we're on this part here, it gave in part A the annual cost of television A. Too many students actually went and recalculated that, or tried to recalculate that and didn't even come up with the same answer, didn't realise there was an issue there. My point initially, though, is that they don't need to. When we give information like that, we need to make sure that they understand we don't have to work it out. We're wasting time doing that. Here's the amount. Let's just do the other part that we need to do. The only time that you need to calculate something that is given is if it's a show question. Okay, most students were able to get some marks in this question. It generally came from doing something with the 160 watts of power consumption, converting that to kilowatts and multiplying it by the cost of 25 cents. If they were able to get some mixture in there of showing part of the correct working, then we could give them some marks. The other part to this first, for part A, is that it actually said what is the difference between the two things. So they actually had to show a subtraction between their calculation and the one that was given. And that in itself was enough. If they actually showed the calculations, that was enough for them to be saying, well, we know what to do to answer that last part of the question. Students who were successful in part A were generally able to get some marks in part B. So if they could get 2 marks in part A, they generally got at least 1 in part B. Some of them that forgot to do the subtraction in part A then did it in part B and used it successfully. Some of the common errors. They only found 1 day's cost. So we used this TV for 1 day. It's 160 watts, times it by 25 cents with the appropriate conversions. And that was the cost. It's not surprising, I'm sure, that they didn't convert, or they incorrectly converted from watts to kilowatts. As I've said before, multiplied by 25 or 25 cents, but then say the answers in dollars, very similar to the tax question. And they didn't find the difference between the two TVs. So they found the cost for TV B, which is great, but they needed to find the difference as well. There was actually a fair bit to do in part A for 2 marks. Many of the students use the cost of 1 year as part of the initial costs. So if in television A, it says that the television cost $900, and for 1 year's usage, it was going to be $48.18. So they said, well, the initial cost is $948.18. Because of that, they then had the answer for part B was out by a year. So students need to realise that the given information doesn't need to be recalculated. Too many of them took up so much time and they just wasted the opportunity to get the marks, unless it says show that or prove that. When using a previous part answer to answer a latter part, students need to check the reasonableness of the earlier answer when they can't get an answer to the latter part. So many of them got a situation where in part B, it was never going to marry up, that the two costs would equal. It was always going to be that television B was getting further and further away from television A, which should have triggered, hey, this says how long will it take? We need to go back and have a look at my answer to A, because I'm not getting to a situation where I can answer B. It's not, we haven't yet been asking questions where there is no answer to this. There is an answer. If you can't get it, maybe you need to go back and have a look at a previous part. One of the other things that students do need to realise they have to do is, if they're using an answer from a previous part, they must show that answer being used in their calculations, because if they get part A wrong, but they show us how to use it correctly, they can still get full marks in part B. Now move on to question 35. It's early in the second booklet of the written paper, but it did seem as though students were starting to switch off. There's not much in the second booklet. It seemed like students had had enough, and certainly the two questions I'm going to go through with you now did have that as an issue, that the students had enough. So this one is a quadratic model. They needed to be able to identify the turning point and substitute into a formula. So we had a quadratic model. Again, it has a section which is not relevant to us, and this comes back to the standard 1 as well. Students need to see here, we might go through and deal with parabolas, etc., with the students, but sometimes these don't, it doesn't work with sections of the graph. The graph is only useful in these parts. Many of the students were able to identify on the graph where the maximum revenue occurred. Now, by that I mean they were actually able to show, put a mark, this is the turning point, this is where I need to find, whether that was on the x-axis or on the graph, or even better still, an axis of symmetry. That showed that they had some idea about what they're actually trying to find. Another positive was that many of the students were able to determine the vertical intercept of the graph. And what was even better was that they could actually just write it, which implies that they understood that the constant term of the equation that was given was actually the answer that they needed. Common errors. Well, the biggest issue that we had was students weren't able to get the X value for the turning point. And some of the common things they did were they just looked at halving 100, because we're only dealing with that part above the axis, from 0 to 100. They actually said, oh, well, the whole gap is 110 and halve that, so the answer is 55, which was a little bit of an annoyance, because the actual answer they needed was 55 as the publisher's price that they should charge, but they weren't showing us that. And the third point there is what was the issue was that they were getting an answer and then not showing us plus 10 to get they got the X value, but then they didn't get a plus 10 to get the second mark. Some of them used a guess check approach, but it was near enough is good enough. They didn't actually do enough checking to get somewhere. Similar to what I've said in the standard 1 question, we need to give them more exposure to the real life situations of nonlinear models. They need to have a greater understanding of the models, not just that we can deal with parabolas or hyperbolas, etc., exponentials. It's okay, in this model, what's relevant? And so I think we need to work a little bit more on that as part of the coursework that we do. And the last question, this was surprisingly, even though I said before that they were obviously getting to the end and switched off, there were still quite a few students had a go at this. It was a Z-score table, probability tables question. They needed to recognise that they were using table values and that table value represented the probability from 0 to whatever the z-score was, and they needed to be able to calculate a z-score. They were the main components. What I said from 0 to z, there's the shaded section in the graph there, meaning that was the component that was given. But the question required that they had the part above the z-score. So they had to realise what to do. So in this question here, part A says, using the table, show the probability is that amount. So a lot of students couldn't get that. Some of them actually said, went further than what they needed to. They said the whole probability was 1 minus a half, because we didn't need the whole of the left-hand side, minus the probability of 0.3. That gave them the correct answer. Some did what was intended, I believe, from the question, which was, well, it's a half, take away the part that's shaded, being 0.1179 to give the answer. But a lot of them used the concept of the 68, 95, 99.7, trying to make that work somewhere. They used a whole lot of stuff and just had no idea how to get the answer to that part. But they did actually have a go. The main thing was in the second part. And one of the things I think we need to talk to students about is, generally, if there's a question that says show, and then a part that follows it, you're going to need to use that show part. The whole point about the show is it does work. This is what it is. Now, it's something that you can use. Even if you can't show it, you know that it does work, so use it. Many students found a z-score for part B. That was a positive, but I'd have to say there weren't too many other positives that came from it. The biggest things were that they didn't recognise that the table gave the value from 0 to z, when what they were required was greater than the z. So there needed to be a subtraction part coming in place there. They were in part B, they were incorrectly putting the values into the z-score formula. One of the biggest issues was having the mean and the score that they were dealing with in the wrong order. So if you go back to this here, they'd have swapped the top line of the z-score answer around. That was one of the most common ones. As I said before, they wanted to use 68%, 95%. What some of them were doing was they got the z-score correct. Then they started to look at it and say, oh, well, this part here is 34%, from 0 to here is 34%. So take my answer away from 0.34 and then multiply by 1,000. They were doing some very strange things there. So I think we need to spend more time using these probability z-score tables as opposed to just going through routine things. They did also do a lot of, here's the z-score, multiplied that by 1,000, instead of, first of all, converting the z-score to the probability and then multiplying by 1,000. So they left out a step. So students need to know the difference between using a z-score probability table and the normal distribution information that's on the reference sheet. So that's 68, 95, 99.7% workings, because there was too much of that combination happening there. They need to practice using the tables and working with things that require probabilities greater than a certain Z-score or between two Z-scores, and also involving negative Z-scores. So we need to change it up a bit, do a bit more practice with them, because if the exam committee looks at what's happened here, I would think that they will want to test again to see whether there's been improvements by students. And that finishes my analysis of the questions that my team was marking. Thank you very much.